I hope that with our presentation so far, we have managed to shed some light on many terms and processes related to working with data and data science. To solidify the concepts mentioned, let's give a brief summary of our infographic and refute some common misconceptions about a few areas of the data science job. Saying 2,000 lines of data constitute big data is simply not true. As we already said, we must consider many things before defining a dataset as big, and volume is just one of them. Big data is also characterized by the variety of data types involved, the variability of sources the information has been retrieved from, the velocity with which it is processed, and so on. Therefore, don't consider a dataset big just because it fills plenty of rows. When it comes to BI, remember that you should be able to distinguish quantitative from qualitative analysis. Not every type of analysis can be considered business intelligence, though. BI deals with the explanation of past events using data-driven approaches and reaching data-driven conclusions. In contrast, a business analytics approach, which is not data analytics and therefore not BI, is SWOT analysis. SWOT analysis is a famous type of qualitative analysis contributing to the strategical decision-making of a company. It points out the strengths and weaknesses of running a particular business. So, a SWOT analysis can improve the firm's strategy, but it is not a data-driven analysis. Great! We can say people often associate traditional statistical methods with tough coding and super quantitative mathematical and statistical models. However, this is not always the case. R and Python are not the only tools you'll need if you are working in this sector. Storytelling is a crucial skill for a data scientist. They should have the ability to express complex mathematical and programming concepts to end users, such as company managers and high-level executives, in only a paragraph and a single visualization. To achieve this, software tools such as Excel, Stata, and SPSS are still frequently used. Finally, since machine learning and AI are not particularly old disciplines, and because they are tightly woven to the evolution of technology, many developments are still ongoing. As such, these developments are surrounded by disputes from scientists and academics who have not reached firm conclusions. For example, it is well known that deep learning algorithms may let a model perform exceptionally well. However, it is still unclear exactly how a machine can obtain such outstanding results. There are numerous scientific papers looking precisely into that problem, but for the moment, progress on the topic is limited. This was the last stop of our introduction to the world of data and data science. We started off with a specific goal to clarify the meaning of the most frequently used terms and buzzwords in the field, and we hope we managed to achieve it. Now, you can confidently go further by exploring each of those in depth. We would like to repeat that we cannot guarantee our infographic will keep you out of the controversy of those terms and fields, as they are strictly interrelated. Nevertheless, we hope you have enjoyed watching these videos and have broadened your overview of the disciplines mentioned. Well, that was it. We would like to invite you to continue with the next part of our training, where we will actually teach a large part of the techniques and skills mentioned in these lessons. We've just began our journey. For the time being, we will never get tired of saying, thank you for watching.